No. Recording is in progress, peeps. Let's go. Get ready to rumble. Yeah, I love the background. I know a student made this for me and sent it to me and said, "Sir, please use this as the background." So I was like, "Okay, let's go. Let's go, guys. Let's demolish some questions. Let's, like you guys say. How do you guys say it? We ate that paper. So let's eat the paper together. Let's start. Hey everybody, we're live and in studio. Now we're going to look into the 2024 set for haloalkanes. These are MCQs, and without further ado, let's just hop into the first MCQ, which says when X is added to sodium hydroxide aqueous and heated under reflux, pentan 2-ol is made. So effectively alcohol, pentan 2-ol, whatever it is, I couldn't care less, but it's an alcohol, right? So an alcohol is made, and how is an alcohol made? You added sodium hydroxide aqueous to X, and you've studied this before. If you recall your mind maps, you know that when you have sodium hydroxide or potassium hydroxide and it's aqueous, it's basically a nucleophilic substitution reaction taking place, and that's with haloalkanes. So X effectively, what is X? X is effectively a haloalkane. And sir, how do we not confuse it with an elimination reaction? In elimination reaction, it's sodium hydroxide ethanolic, because the only difference is in elimination between elimination and nucleophilic substitution for haloalkanes is the fact that if it's nucleophilic substitution, you must have aqueous, and if it's elimination, you must have sodium hydroxide in ethanol, because in ethanol, you'll realize that the hydroxide ion behaves as the base, and in aqueous, the hydroxide ion behaves like a nucleophile, and we've already studied that in a lot of detail, right? So yeah, that's the idea. Now somebody saying my ears, okay, sorry. So now he's saying which organic product is made when X is heated with KCN dissolved in ethanol? Sodium cyanide or KCN, it doesn't really matter. NaCN or KCN, when it's dissolved in ethanol, you know that there's going to be the cyanide ion involved, and there's going to be a nucleophilic substitution reaction taking place with the haloalkane. Now, a couple of things to note is that the alcohol which is made is pentan 2-ol, which means that it must have 5 carbons, right? So pent means 5 carbons. The alcohol has 5 carbons, and that means that the haloalkane you have must have also how many carbons? 5 carbons. And because you have pentan 2-ol being made, what that means is 2, 3, 4, 5. What that means is the OH is on the second carbon right here. That's pentan 2-ol. That means that the haloalkane that you had, also had the Br or the chlorine atom or the Br atom on the second carbon right here. Right? It can be any atom. I'm adding Br, but it could be chlorine, it could be bromine, it could be iodine. I couldn't care less, right? So this was effectively your haloalkane. Br, Cl, I don't care, but and a nucleophilic substitution reaction took place. And let's suppose the SN2 mechanism took place. What that means is, let's suppose, I'm just assuming because it's a secondary haloalkane, it's not a tertiary or a primary haloalkane. So for secondary, we can't really tell. It can either be an SN2 mechanism taking place or an SN1 mechanism taking place for secondary haloalkanes. Let's suppose SN2 takes place, which is bimolecular. What that means is you have two fellas involved, the OH minus ion. The OH minus ion, what it does is it attacks this partial positive carbocation, boom, right here. Sorry, why am I calling it carbocation? What the hell, Salman? Partial positive carbon. It's not a carbocation, partial positive carbon. And once this fella attacks, this lone pair attacks this fella right here, the nucleophile attacks this fella, what happens is simultaneously this bond breaks, a transition state is made, an activated complex is made. I'm going to skip that out, but effectively what happens is you end up with pentan 2-ol like this, and you have the bromide ion, right? Breaking heterolytically. So that's the idea. So effectively we realize that X must look something like this. This is what X is. Now he's saying that further what happens is that X is heated with KCN, and the reason why you're heating it with KCN dissolved in ethanol is because now you want the cyanide ion to attack the this haloalkane, and if the cyanide ion attacks this haloalkane, the CN will bond instead of the Br, right? So what's going to happen is 2, 3, 4, 5. I'm not going to show the mechanism. It's just going to be a CN being bonded instead of a Br atom, right? And what you also realize is now because you are adding the cyanide ion, you're going to have one more carbon. So instead of having 5 carbons, you are going to end up with 6 carbons. So one more carbon. You can do these MCQs really quickly. I'm just going over every single detail to be discussed in this MCQ to revise your concepts effectively. You can solve this MCQ in 15 seconds, by the way. How? Because what you realize is, hey, if you had an X fella with 5 carbons, now if you were to react it with KCN, it must have 6 carbons. So start counting the carbons first. 1, 2, 3, 4, 5. These are 5 carbons. A can't be correct. 1, 2, 3, 4, 5. These are 5 carbons. B can't be correct. Now let's look at C and D. C and D has how many carbons? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So C and D both have 6 carbons. And what you realize is, hey, because pentan 2-ol was made initially, that meant that the haloalkane was a 2-bromo or a 2-chlorohaloalkane or a 2-iodohaloalkane. So the cyanide ion must also be on the second carbon, and therefore C is incorrect. D is the correct option. See, you could have done this really quickly, but I just wanted to discuss some further details with you. Done? Does sir upload these recordings on YouTube as well? Yes, mumbo jumbo, I absolutely do. Sir, I love your background. I love it too. Thank you for showing love to my background. Next question, 1 chlorobutane and 1 iodobutane. So one is effectively C bonded to a Cl, and in 1 iodobutane it's basically C bonded to an I, right? And it says both react with aqueous sodium hydroxide by a nucleophilic substitution mechanism. Obviously an alcohol forms. If you have sodium hydroxide aqueous, alcohol forms, and if you have sodium hydroxide ethanolic, then what forms? Alkene forms, right? It's an elimination reaction then. And we know why. We've studied all the mechanisms for it even. I think which fella has the greatest rate of reaction? Now, the greatest rate of reaction would be of the fella which obviously is bonded to the iodine, the C bonded to the I. That's the one which will have the greatest rate of reaction. And what's the reason behind it? The reason is the Ci bond is weaker than the CCl bond. So because the Ci bond is weaker than the CCl bond, it's going to break more easily. And if it breaks more easily, it will react faster. And why is it weaker? Because I is a larger halogen atom. And because I is larger, it is a longer bond. Longer bond and lower bond dissociation energy. We've already studied all of this stuff. So longer bond, weaker bond, less orbital overlap even, So that's the idea. And we've studied this in a lot of detail in the live classes. So realize that the Ci bond can break much more easily compared to the CCl bond, which means that it'll be the iodo fella which will have the greatest rate of reaction. So A and B are automatically wrong. Now, what would it undergo? Would it undergo SN1 or SN2? Because it is 1 chloro and 1 iodo, that means what? That means it's a primary haloalkane. It's only connected to one alkyl group. See, meth, eth, pro, but, and it's 1 iodo, right? So I'll add an I here. And so what that means is, see, this carbon is bonded to a halogen atom and it's bonded to one alkyl group. So what that means is this fella is a primary haloalkane, and primary haloalkanes undergo SN2 mechanism, because see, SN2 is what? Effectively this is bimolecular, and bimolecular means what? Bimolecular means 2 molecules are involved in determining the rate. And why are 2 molecules involved in determining the rate? It has to do with steric hindrance and all of that good stuff. I've already taught that in a lot of detail, wherein a lot of teachers teach it absolutely incorrectly. SN2 क्यों होता है, SN1 क्यों होता है. This is bimolecular. There are 2 molecules involved in determining the rate of the reaction. You can check out my YouTube video on SN2 and SN1 and the differences between them. This is single step. SN1 is 2-step mechanism. This is single step, and all of that good stuff. SN1 is undertaken by the tertiary haloalkanes, and the reason for that is pretty simple. It has to do with steric hindrance and all, but nobody cares as of now. So which mechanism would it undergo? It would undergo SN1 or SN2? Obviously it would undergo SN2 mechanism. Primary haloalkanes, for your course, I'd say I've explained it in a lot of detail, but for these MCQs, remember, primary haloalkanes would undergo SN2, tertiary haloalkanes would undergo SN1, and secondary can either undergo SN2 or SN1. We couldn't care less. Next question. Hanji, what is Farina saying? Sir, is there a way I can learn mechanisms and not mix them? Yes, Farina, take my classes. That's the way. I'll also conduct a live organic chemistry marathon which will be probably a 4-hour class, in which I'll be discussing every single reaction and every single mechanism in the form of a mind map. So hopefully, Farina, if you take that class, that'll be more than efficient and more than sufficient for you to remember everything. When will you take it? Hopefully this coming weekend. Please take it before Sunday. Chalo, inshallah. The diagram shows a synthetic route to produce 1-methyl cyclohexanol. Couldn't care less. Now you say, why don't you care less? Every time I read a question, I say couldn't care less, because I'm just too cool for it. I'm too cool for school. Yeah. Now he's given me a cycloalkene and a methyl fella attached to it, and he's reacting it with HBr. Now when the examiner is reacting this with HBr at room temperature and pressure in a dark room, these are normally the conditions for it. What will happen? The double bond will break. Where will the H go and where will the Br go? That's the question. See, product X, because the examiner has not stated anything, we will always assume that product X is the major product. And what is the major product? The one in which the more stable carbocation intermediate forms. And where is the more stable carbocation intermediate? Will it form here when the double bond breaks, or would it form here when the double bond breaks? Obviously it would form right here, because see, this carbon would be bonded to 1 alkyl, 2 alkyl, 3 alkyl groups. So this is the tertiary carbocation intermediate, which is more stable than the secondary carbocation intermediate. What that means is the hydrogen would bond here, and the Br would then, in the second step, after the intermediate forms, then the Br minus the bromide ion would attack this fella, and the Br would attach here, right? Or you could remember a rote learning idea behind it, which is Markovnikov's rule, which is the fact that when the double bond breaks, the hydrogen bonds to the carbon with more hydrogen. This carbon has 1 hydrogen bonded to it, and this carbon has no hydrogen bonded to it. So effectively the hydrogen goes here and the Br goes here. It's up to you how you want to rote learn things, right? But it should be the concepts, the alkyl inductive effect, that should come into your brain and read. So here the Br would go after the double bond breaks, and here the hydrogen would go, right? And that would be the major product with you. The minor product would be opposite. The hydrogen would go here and the Br would go here. That would be the minor product, because that would have been formed through the less stable carbocation intermediate. So that's the fella. Now he's saying after this fella forms, and even make it right here, this is CH3, this is Br, and this was the hydrogen with bonded here. Now what he's doing is he's heating it with reagent Y, and an alcohol is forming. See, look at the difference between X and Y. What's the difference between X and, let's call this Z? What's the difference between the structure of X and Z? The only difference between X and Z is that instead of a Br, you have an OH. And how can you go from a haloalkane into an alcohol? How do you go from haloalkane to an alcohol? How? You use NaOH, but not ethanolic. It must be aqueous and heat under reflux, or you can use KOH, aqueous and heat under reflux, right? See, Raima, that just goes on to show concepts are clear. If it's ethanolic, then it must undergo elimination reaction. Then alcohol wouldn't form. Haloalkane would go back into alkene. And I've discussed it in quite a lot of detail. So C is incorrect. Now, cold dilute KMnO4 would not form either or. Cold dilute KMnO4 would just break this double bond, and you would get an OH here and an OH here, so you would just form diols with cold dilute KMnO4. And here with D, hot conc KMnO4 would cause oxidative cleavage. It would completely rupture the carbon-carbon double bond. So that's also not correct. And what therefore that means is that A is the correct option right here, because A, the hydroxide ion, behaves like a nucleophile in aqueous state. And so what happens is this OH minus would attack this guy, the Br would break, and you would end up, and obviously it's gonna be which mechanism would it undergo? Would it undergo SN1 or SN2? Because this is a tertiary haloalkane. See, this carbon is bonded to CH3 and this fella and that fella. So because it's a tertiary haloalkane, this would undergo the SN1 mechanism, because it's energetically more favorable for it, right? Easy. Sir, can we just say alcohol was made so NaOH? Sure. However you want to think about it, guys. I am solving these MCQs with the utmost clarity and detail. As an AS level student, you are supposed to do these MCQs really quickly. It shouldn't have taken you more than 15 to 20 seconds to solve this MCQ. There's nothing in it. There's nothing, literally nothing in it. I am just going over extra details. Next question. Question 30. Read the question, guys. X and Y are reagents required to convert 1-bromopropane into butanoic acid. And see, you just look at the differences. If you look at this fella and this fella, what's the difference? You went from a haloalkane, a halogen atom, to a cyanide being added, to nitriles. You went from haloalkane to nitriles. How do you go from haloalkanes to nitriles? Again, NaCN or KCN, and it must be ethanolic. It can't be aqueous, because if it's aqueous, then the OH minus in the water could cause this fella to go into an alcohol. So it must be ethanolic and heat under reflux. Why? Because obviously you have these haloalkanes are normally volatile, so we don't want them to escape. We want a good conversion product, and that's how you end up with nitriles. See, this is how easy these things are. So you went from haloalkanes to nitriles, and then from nitriles, how do you go from nitriles to carboxylic acid? That's the most lovely part that the examiner always tests, which is the fact that you can go from nitriles to carboxylic acids by just performing hydrolysis. And how can you perform hydrolysis? You can perform hydrolysis by either using dilute acid or by using dilute alkali. But remember, if you use dilute alkali, you won't get COOH directly. No. You'll get the carboxylate salt. You're going to get COOH, and if, for example, I used sodium hydroxide dilute, then I'm going to get COO. Instead of getting COOH, I'm going to get carboxylate salt, which is COONA, right? COONA, and this is minus and that's plus, sorry. And then you have to further acidify this. So further acidify with dilute acid to form carboxylic acid. So remember, in this case, if he's saying that from nitriles you ended up with carboxylic acid and that's hydrolysis directly, that means that you've used dilute acid instead of dilute alkali, because if you use dilute alkali, you end up with the salt first and then you further acidify that salt. Right? So that's the idea. Now he's saying, what is X? X is NaCN or KCN. Remember, in organic chemistry, wherever you're using sodium compounds, you can substitute that for potassium compounds as well. So see, NaCN and ethanol, this is ethanolic, right? It's saying NaCN in ethanol, and that's absolutely correct. So therefore A and D are wrong, because A would give you amines. A is ammonia. Remember this idea? Ammonia and heat in a sealed tube under high pressure. And HCN, this is where they've confused you. HCN is absolutely incorrect, because where have you seen HCN other than this? You see HCN plus NaCN and heat. Where have you seen this before? This is for carbonyl compounds. This is to take aldehydes and ketones, convert aldehydes and ketones into hydroxynitriles, remember? And we've studied the nucleophilic addition reaction and the mechanism for it, so couldn't care less. Now, what is Y? Is Y sodium hydroxide aqueous, or is it HCl aqueous? Now, again, it can be both. You can perform hydrolysis with dilute acid or with dilute alkali, but the step that he's shown you is that you went from nitriles directly into carboxylic acid, right? He could have used either or, but if you were to use sodium hydroxide aqueous, first you would end up with the salt and then you would further acidify the salt, but that's not the case, which means that he's not used sodium hydroxide aqueous. He has used hydrochloric acid to acidify it, right, or to perform the hydrolysis with. So C is therefore the correct option. आसान है MCQs, इसमें क्या है? The table shows 3 set of reagents and reaction conditions at roux reaction condition. Which set of reagents and conditions can be used to produce 2-chloro-2-methyl propane as one of the organic products? Let's first make 2-chloro-2-methyl propane. Let's make the longest chain, which is propane. Then you have a chlorine atom on the second carbon and a methyl on the second carbon, right? So effectively, this is how it looks, right? This is the structure of 2-chloro-2-methyl propane. Now I'm saying, okay, which of these sets will give you 2-chloro-2-methyl propane? Let's check it out. If you have this fella, CH2, CH3, CH3, right? If you were to make this, see, this is how it looks. CH2, then it's bonded to a C, which is bonded to a CH3, which is bonded to another CH3. And effectively what that means is the examiner has not shown you the double bond. CH2 is actually having a double bond with this carbon, because otherwise this has the incomplete valencies, right? It can't be CH2 single bond with carbon, because where does the fourth bond go? This carbon can't make just 3 bonds. Where does the fourth bond go? So you understand, okay, hey, this is basically a double bond. So effectively the examiner has shown you this. Right? And if you use HCl gas at RTP, this can absolutely happen. This is the electrophilic addition reaction with alkenes. The double bond is going to break and you're going to end up with what? You can actually end up with a chlorine atom being bonded here and the hydrogen atom being bonded with this carbon right here. And normally it's going to happen. That'll be the major product for it, because the carbocation intermediate that would form is going to be the more stable version of it, and the most stable carbocation intermediate is right here, which will be the tertiary carbocation intermediate. So the hydrogen would bond here and the chlorine atom would then, the chloride ion would then attack this fella and bond with the tertiary carbocation intermediate to give you guys 2-chloro-2-methyl propane. So the first option is absolutely correct. This will in fact result in 2-chloro-2-methyl propane. It can also end up in 1-chloro-2-methyl propane, but that'll obviously be the minor product. That's the major product, right? Now, the other fella, CH3 bonded to a carbon, then it's bonded to a CH3 and the OH, and then it is CH3, right? So if I were to show it to you, see, it's CH3 bonded to a carbon, which is bonded to a CH3, which is bonded to the OH, and that is further bonded to a CH3. Effectively, if I were to show you the skeletal for it, I draw it like this because not a lot of you guys are familiar with skeletal. So it's 1, 2, 3 carbons, then this fella has the methyl and this fella has the OH, right? So effectively it looks something like this. This fella. Now he's saying it reacts with SOCl2. Now I've always said that, you know, for SOCl2 normally heat is not needed. Normally heat is not needed. I've always said this in the live class. Normally I've said it that normally the examiner, when he asks you KR SOCl2 mein, you write heat with it. You write heat with it. That's the problem with the examiner. But in my live classes, if you listen to me over and over again, I've always said that, see, you need heat for, you know, like if you're adding HCl gas or HCl aqueous, and then you heat here. If you're adding PCl3, you know, you heat. But normally with SOCl2 as well as PCl5, this is at RTP. But in the theory questions, normally the examiner writes SOCl2 ke side, the examiner writes heat as well in the theory questions. But I've always said in my live class that normally heat is not needed for SOCl2 even, if you guys remember. So that's the idea. Now, if you have this fella and you're adding SOCl2, it's basically a substitution reaction. This is how you go from alcohol into haloalkane. So the OH is going to be substituted with what? With a chlorine atom. And absolutely, this is also going to give you guys the product, which is 2-chloro-2-methyl propane. And then the last one, it's saying CH3, CH3, CH3 with chlorine, the presence of ultra UV light. If you draw the structure for it, you can absolutely do it. You know, CH3, C bonded to a hydrogen, bonded to a CH3, and then this is bonded to a CH3, right? This is the structure for it. It's effectively an alkane. And you know that if you have an alkane and you react it with chlorine in the presence of UV light, you know that this is going to be free radical substitution, and one of the product can effectively be 2-chloro-2-methyl propane. Because see, on the second carbon you already have methyl, and this hydrogen right here, this hydrogen can be substituted for a chlorine atom. You can end up with, you know, the methyl will be here, and you can end up with the chlorine atom substituting this hydrogen right here. So this can also happen. And so all these three options are effectively 1, 2, 3. All these three options are correct, and therefore A is the correct option. Can you explain statement 1 again? Sure. You want me to show the mechanism for statement 1? This is the structure of statement 1. Now, if you use, or chalo, those who are not that well versed with skeletals, this is the structure for statement 1. Now if you have HCl, what's gonna happen? This is partial positive, this is partial negative. The lone pair would attack this fella here. This would break heterolytically. This would be the carbocation intermediate which would form right here. The hydrogen would bond here. You know, these two are hydrogens effectively. And then the chloride ion would attack this guy right here, and you would end up with CH3 bonded to a C, bonded to a CH3, bonded to a CH3, and bonded to a chlorine. This is even, I've even shown you the electrophilic addition mechanism for it. Happy? That's statement 1 for you. Guys, you must be good with these things. If not, watch my organic chemistry videos. These are very easy. There's nothing, you know, rocket sciencey about this. Any questions? Easy, Murtaza? Suleiman, good? Are you happy? My name is also Suleiman, but with a double A. So I hope it made sense now. Sir, is 2 correct? Yes, 2 is correct. Fatma, I literally explained 2 here. It's a substitution reaction. Remember how you went from alcohols into haloalkanes. SOCl2, PCl5 for chlorine, for bromine. Doesn't the examiner require heat? I'm confused. What do you mean, doesn't the examiner require heat? I said in theory you normally write heat, but if you listen to my live classes, I've said it a billion times that SOCl2 and PCl5 dono ke liye heat nahi required. You can rewatch my live classes over and over again. But if it's a 2-mark question in the theory paper, you normally write SOCl2 and heat with it if required. I've said it a billion times. I hope so. Both work, yes. Heat works regardless. See, in PCl5 you don't need heat, but you can even provide heat. There's no problem with it, is there? But like PCl3 and HCl, they won't work without heat, so you need to provide heat here. Here, not necessary, but normally in theory questions you must have seen this in the marking schemes where SOCl2 is used. They also write heat with it for God knows whatever reason. I don't know. Probably for the rate of reaction. Done. Question 6. Structural isomerism and stereoisomerism should both be taken into account when answering this question. Okay. The structure of 3-methyl cyclobutene is shown. A mixture containing all stereoisomers. Now remember, stereoisomers can be optical, where you have a chiral carbon. And what is a chiral carbon or a chiral center? In which you have 4 different group of atoms or 4 different atoms or groups attached to a carbon, right? Or it can be geometric. And geometric isomerism takes place when you have 2 different groups A and B. When you have 2 different groups A and B bonded to each of the carbon in the double bond. Done. That's where cis-trans isomerism or geometric isomerism is gonna take place. Now, he's saying a mixture containing all stereoisomers of 3-methyl cyclobutene, which is this structure right here, is treated with HBr. Okay. Now, when this fella is treated with HBr, the hydrogen can go here and the Br can go here, or the Br can go here and the hydrogen can go here. We couldn't care less, right? Both possibilities need to be taken into account in this case. He's saying this produces a mixture of isomeric bromomethyl cyclobutanes. Okay. How many bromomethyl cyclobutanes, right? What that means is he's basically saying that the HBr may H can go here, Br can go here, Br can go here, H can go here. You can have a mixture of these many isomeric products. Now he's saying how many stereoisomers does 3-methyl cyclobutene have? Now before we move forward, let's first discuss 3-methyl cyclobutene. How many stereoisomers would 3-methyl cyclobutene have? Number 1, if you analyze the structure, you have a chiral carbon right here. You have absolutely a chiral carbon because this carbon is bonded to a methyl group right here, right? And then this carbon, you see the anti-clockwise structure and the clockwise structure. They are both different because you have a CH3 here. The 4th bond, which is not shown, is obviously with hydrogen. So you have a CH3, a hydrogen, and then the anti-clockwise structure and the clockwise structure, they are both different. If you go clockwise, you get a CH2 first, then CH, then CH, then CH2, then a CH, right? So CH2, CH, CH. And if you go anti-clockwise, you get CH, and CH2, right? So they both are different, and that's why it makes this fella as a chiral carbon, right? So you can have 2 optical isomers because of this, which will be the non-superimposable mirror images of each other. Now, there's one question that a lot of students are going to ask here. There's one question that a lot of students are going to ask here, and that question is, sir, okay, 2 optical isomers exist. That's good stuff. We understand that. But what about this fella? Wouldn't this guy exhibit cis-trans isomerism? Now, for cis-trans, you realize that you must have the carbon in the double bond. Each of the carbon in the double bond must be bonded to 2 different groups or 2 different atoms. Now, this fella is bonded to a hydrogen and it's bonded to this guy, and this fella is also bonded to a hydrogen and is bonded to this guy, right? Now, what you understand from this is, and this is the cis version, by the way, this is the cis fella. Now, what you understand by this is, hey, a geometric isomer, a cis-trans isomer would also exist here, wouldn't it? A cis-trans isomer would also exist here. Now, it is very pathetic of the examiner to test these concepts because these concepts are long gone from your Cambridge course. But it's been tested twice now, in the 2023 MCQs when we were doing it, and in the 2024 MCQs when we are doing it right now, is the fact that, remember this as a rule, remember this, because the concept isn't part of your course. The strain concept and all, that's not part of your course. But remember this as a rule, I'd suggest as of now, which is that, hey, although you might realize that cis trans isomerism does exist, and you would say, hey, 4 stereo isomers are there because 2 to the power 2, that's 4. You might say that, but remember, if you have a cyclic alkene, remember this as a rule now, because I just can't be bothered with the Cambridge examiner. So if you have a cyclic alkene and it has less than 8 carbons in it, it has less than 8 carbons, even if the carbon-carbon double bond exhibits cis trans, in your opinion, it's not going to do that. It's not going to do that. Because understand that this, in the cyclic alkene, the carbon-carbon double bonds are fixed for lower cyclo compounds. And what you realize is, hey, in cyclic fellas, in cyclic alkene, if you have a double bond, because the double bond is fixed, the trans version never actually exists. For alkenes, for cycloalkenes, which are lower than 8 carbons, the trans version never really exists. What's the reason? The double bond is literally fixed. Right? It's fixed. You can remember it like this. The double bond is literally fixed. Only the cis version exists here. The trans version does not exist. Yes, Cambridge is bipolar here. So if you have a huge structure, then it can exhibit cis-trans isomerism even with the double bond. But if you have 8 or more than 8 carbons in it, but if it's fewer than 8 carbons and you have a double bond, even though it would fulfill the condition that each of the carbon in the double bond is bonded to 2 different atoms or 2 different groups of atoms, please say that it will not exhibit cis-trans isomerism. The examiner will never ask you the why behind it. Just know it as a rule, therefore, which is the fact that these lower carbons, they are so fixed, the double bond is so fixed that the trans version never really exists. It's highly unstable, never really exists, right? So that's the idea. So between A, B, C, D, I can cross out C and D, you know, because this type of MCQ was tested before and I gave you the entire concept behind it, but I just can't be bothered with the Cambridge examiner at this point in time, right? So between A and B, I have to select. Now he's saying bromomethyl cyclobutanes. What about this? Now let's talk about this. See, the first fella that's going to exist is you can have a hydrogen being bonded here and a Br being bonded here. That's the first idea, and this is obviously methyl. And the second idea is that you could have a Br being bonded here and a hydrogen being bonded here, and that's obviously your methyl. Right? Now, first of all, let's talk about optical isomerism here. Let's talk about optical isomerism. If I look at this fella and B fella, do I exhibit optical isomerism somewhere here? Do you see optical isomerism being exhibited in A? Absolutely. See this carbon right here. This carbon is bonded to a Br, is bonded to a hydrogen, and then it's bonded to this side of the fella. The anti-clockwise and the clockwise cycles, they are not the same, which means it's bonded to this entire side and that entire side. So this fella is chiral. The cycles are the same. And if you look at this carbon, it's bonded to CH3, it's bonded to a hydrogen, and it's bonded to this cycle and this cycle, and the anti-clockwise cycle and the clockwise cycle aren't equal, aren't the same. It's not symmetrical, and therefore this fella is also chiral. So it's 2 to the power 2. You get 4 optical isomers here, don't you? Could you explain B again? What do you mean, Hafsa, B? I've not even talked about B. I just said when the double bond breaks, you can have a Br go here and a hydrogen go here, or a hydrogen go here and the Br go here, because it's HBr being added. We have to explain both the options, right? So you can have 2 to the power 2, 4 optical isomers here, 4 optical isomers. Done? Now, that's good. And if you look at B, if you look at this B fella, would this exhibit optical isomerism? See, I'm going to erase this hydrogen because obviously we don't show hydrogens. We don't show hydrogens. I just wanted to show it to you for the purpose of telling you that on one side the H bonds and the other side the Br bonds, but I'm going to erase this. I'm going to erase this for a reason now. Why? Because if you look at the B structure, this carbon, you might think it's chiral, right? You might think it's chiral because there's a Br bonded, there's a hydrogen bonded. But if you look at the cycles, the clockwise cycle and the anti-clockwise cycle, they are both the same. They are both symmetrical, right? See, you go from carbon, this is CH2, then it's CH3, and then it's CH2, and you come back. And similarly here, this is CH2, CH3, and then you go here, CH2. So the clockwise cycle and the anti-clockwise cycle are the same. Therefore, this fella is absolutely symmetrical. And because it is symmetrical, optical isomers do not exist. Aren't there? Right? So this, even if you look at this carbon, you might think, say, there's a hydrogen, there's a CH3, but if you look at the clockwise cycle and the anti-clockwise cycle, they're literally both symmetrical. The clockwise cycle and the anti-clockwise cycle are literally both the same. What that means is neither this carbon is chiral nor is this carbon chiral. Done. But there's something special about this fella. There is something special about B. What's special about B? Or even A? You could either discuss B or A, which is the fact that cis-trans isomerism would exist here. Geometric isomers would exist here. Why would geometric isomers exist? Because see, the idea is if you have cycloalkanes, and I've taught this in my live classes, if you go on to the first 15 videos of my recordings in which I've discussed introduction to organic chemistry, in there I've talked about cycloalkanes. Cycloalkanes do exhibit cis-trans isomerism because the structure is locked. So there will be cis-trans isomerism. How will you see cis-trans isomerism? See, either both the fellas will be out of the board, which is they are both on the same side. So this Br and CH3, this will be the cis version, or one will be out of the board and the other one would be into the board. Right? And this is the trans version of it. And I've discussed this, by the way, in where I was teaching you guys the namings, the number of isomers that you could calculate. Right? So you can check out the videos for it. Remember, the rule for the double bond is in place, that if you have a cyclic alkene with less than 8 carbons, even if you think that cis-trans might exist due to the double bond, you'd say it does not exist, right? But when you talk about cycloalkanes mein to cis-trans would absolutely be exhibited. This is the cis version, this fella is the trans. If they're both on the same side, that'll be called the cis version, and if they're both on the opposite side, that'll be called the trans version. So in total, how many different fellas do you get? You get 4 fellas here, 1 here, and 1 here, and that's effectively 6. So you get A and B mein aap check kare, one is 4 and the other one is 6. So A is wrong and B is the correct option. This was, by the way, a pretty difficult MCQ to think about. Can somebody check the marking scheme for it as well? Can somebody check the marking scheme for it as well? Please do and let me know. Said it's B. Chalo. It's B. Good. Because I'm doing these questions for the first time, by the way, with you guys. So, ऐसे ही है. Done. This was a technical question. Not gonna lie. It used a lot of the brain power. It's B. Chalo. Perfect. Next. The diagram shows the structure X. Which row is correct? How many sigma bonds are there? See, C bonded to N effectively is C triple bonded to N, isn't it? And so, how many sigma bonds are there? So you have one sigma here, the other sigma is here, sigma, I am sigma, you are sigma, everybody is sigma. How many sigma bonds are here? Sigma 1, 2, 3, 4, 5, 6. You have 6 sigma bonds, therefore A and B are wrong. And obviously, only one sigma bond can exist. The other 2 bonds are obviously pi, and this is the third pi bond, right? Now you think, what is the hybridization of the carbon atoms in X? If you look at this carbon, because it's linearly bonded, see, it's bonded triple bonded to nitrogen and a single bond to this fella. So in total, it's bonded to 2 atoms and no lone pair, and that means it's linear. It is sp hybridized, right? Wherein this carbon and this carbon, because they are bonded in a double bond, this is trigonal planar and this is sp2 hybridized, because trigonal planar is sp2. So sp and sp2 is the idea. So you have 6 sigma bonds and one is sp and the other one is sp2, therefore C is correct. sp3 does not exist here. Why? Because for sp3 you need a carbon to be bonded to 4 different atoms or 4 different groups, x, y, z, whatever it is. 4 different groups nahi, but 4 atoms. Why am I saying different? It can be different, it can be same, but it must be a tetrahedral structure. It must be tetrahedral for sp3 to exist. Next, read this on your own. Q is either a primary or a tertiary haloalkane. Q undergoes hydrolysis with aqueous sodium hydroxide. It's either primary or it's tertiary. And if it's primary, it undergoes SN2. If it's tertiary, it undergoes SN1. The first step in the mechanism involves two species reacting together, and that means it's undergoing SN2, because in SN2 it's bimolecular. There are two species in the first step for SN2 which determine the rate, don't they? So the haloalkane obviously is a primary one, and obviously if it's undergoing the reaction with sodium hydroxide aqueous, it's the nucleophilic substitution reaction, because the hydroxide ion behaves as a nucleophile again. Or A wrong, and B is the correct option. समझ में लग रही है? 2-bromopropane is converted to 1,2-dibromopropane in a pathway involving two reactions. Reaction 1 gives you compound X, and then 1,2-dibromopropane. What are the reagents and conditions for the two reactions? If you look at the options, you have 2-bromopropane, and you go into compound X, and then you end up with dibromopropane, 1,2-dibromopropane. So you end up with a Br being bonded here and a Br being bonded here. Now what is the intermediate step? What you realize is, hey, haloalkane tha mere paas, and you are making the haloalkane all over again. You went from haloalkane to haloalkane, and here you have two Br atoms. So effectively Br2 must be added to something. And what should Br2 be added to? It should effectively be added to an alkene. See, this is how you need to think. If you remember the mind maps, this is the only way where you will remember the intermediates. Because realize, hey, you have haloalkane, you took the haloalkane and made the haloalkane go into the alkene, and then to the alkene you added Br2, and then effectively Br bonded here and Br bonded here. And how do you go from haloalkane into the alkene? You use NaOH or KOH ethanolic. So this is how my brain worked in it. And so if you look at the options, it can't be aqueous, because if it's aqueous, then alcohol would form, right? And how do you go from this fella? See, how do you go from this fella into this fella in a single step? You can't, can you? How can you? Have you studied something like this? You can only go from this fella into a single Br, not di-Brs. Why? You could have used, HBr in this case, or NaBr plus 50% concentrated H2SO4 here. Sir, why didn't we turn it into alcohol and then back into haloalkane? Because I literally showed it to you. If you were to take this fella and go into the alcohol, this alcohol would form. How would you add two Br atoms to this fella? Have you studied something like this, where you take the alcohol and add two Br? Only a single Br could be substituted. This OH could be substituted in the place of this Br by adding, HBr and heating. How would this Br then come? It wouldn't come, would it? Got it? Can you explain reaction 2? Alkene double bond. The double bond breaks, a Br comes here and the other Br goes there. That's how 1,2-dibromopropane forms. Alkene reaction, electrophilic addition reaction. Alkene to haloalkane. So you won't add HBr, would you? Because see, if you added HBr, what would happen is you'd again end up with a single Br atom. And this would be the case with HBr. You need to add two Br atoms. Why didn't you use HBr? Because again, if you use HBr here, the double bond breaks and only a single Br atom bonds here. You end up with 1,2-dibromopropane, which is two Brs. So the only way you could end up with two Brs if you add Br2. Yeah. So C is also wrong. D is the correct option. Next. Aqueous NaOH reacts with one. These MCQs are lengthy as hell to explain. If I started solving them, it would take me, this entire video would have taken me 7 to 8 minutes. I don't know. But I also have to explain simultaneously. That's such a pain in the bum. Aqueous NaOH reacts with 1-bromopropane to give propanol. See, this is how you need to think about it. Okay. Do you know how my brain works? I'll tell you how my brain works. My brain works like this. 1-bromopropane, I don't even look at the compound. What I do is I say, okay, this is a haloalkane. This is how my brain works, and this is how it should work for you. This will make your life easy. Propanol, alcohol. How do you go from haloalkane to alcohol? Then my second question in my brain, the second question is, how do you go from haloalkane to alcohol? And the answer comes directly. NaOH, aqueous, and heat under reflux. This is how I go from using my brain into actually selecting the right option. And I also then know that this is nucleophilic substitution reaction. So this is how you should think about it. Instead of just reading these and then making them for yourself, just quickly think, okay, this is haloalkane, this is alcohol, I went for da. What should be included in the diagram in the first step of this mechanism? Now see, again, it was 1-bromopropane, 1-bromo. It's a primary haloalkane, and primary haloalkanes undergo SN2, which is a single step fella. Single step reaction, right? I can even show it to you. 1-bromopropane looks like this. And in a primary, for a primary haloalkane, how does the the nucleophilic substitution reaction take place? This is partial positive, this is partial negative. The lone pair on this nucleophile attacks this partial positive carbon. Then this fella goes, a transition state forms, obviously, in which you have bonds like this. This is Br, this is the OH, this has the negative charge on it, couldn't care less about this, and then this bond breaks, the Br bond breaks, right? And you end up with the OH. That's how it happens, doesn't it? So it says a curly arrow from the lone pair, which is the OH, on the OH goes to the partial positive carbon on the 1-bromopropane. Yes, absolutely, this is what happens. A curly arrow from curly arrows represents the movement of electrons, remember. Curly arrows represents the movement of electrons. And so electrons don't move from this partial positive carbon to the hydroxide ion. It moves from hydroxide ion, which is the nucleophile, to this fella. So B is incorrect. C, a curly arrow from CBr bond, a curly arrow from the CBr bond goes to the C atom. No, it goes to the Br atom, right here. See, CBr bond, I say it goes to the Br atom. Heterolytic fission takes place. The homolytic fission, no, heterolytic fission takes place. Where is the correct option? I am tired for... Seriously, just did 10 MCQs in 46 minutes. That's crazy wild. I'm gonna pause, take some break, and if I have the stamina, I'll continue. Otherwise, we'll have another part for the second 10 MCQs. These MCQs are so lengthy, I swear to God. It's hurting my brain now. My brain... Koi galti to nahi hai? Have you solved all the MCQs correctly? See, my concepts are clear. I know every MCQ is correct. I'm not like other teachers who, puts the marking scheme in front of their eyes and then solve it. Sir, my attention span is being tested. Sir, how long is this class supposed to be? I don't know, Hafsa. Can we revise tests, organic tests? Not now, Fatma. I'm eating Sour Patch का जो smaller version होता है, that's what I'm eating. I think these are Sour Patch का वो smaller version. These are nice, खट्टे खट्टे. Sir, the class is really fun though. Why not? It's fun for you because you've studied. Love when the brain hurts. My brain is also hurting. Sour Patch क्या होते हैं? इस्लामाबाद में मिल जाएगा. शम्स जाएं, शम्स इधर मिल जाएगा. Sour Patch is like candy. कराची में देख लीजिए जिधर इम्पोर्टेड ये कन्फेक्शनरी होता है, क्या होता है वो मिलते हैं. नहीं, कराची में मिल जाएगा यार. कोई ऐसी दुकान होगी इसमें इम्पोर्टेड चॉकलेट्स और ये चीज़ें पड़ी होती है, उसमें मिल जाएगा. मेरा लिटरली दिमाग दुख रहा है. एक MCQ ने मेरा दिमाग दुखा दी. उसको एक्सप्लेन करते करे मैं टेस्ट हो गया हूँ. Shams is overpriced for real. Absolutely it is. You're absolutely right, Fatma. लेकिन और कोई जगह है नहीं पाकिस्तान में, किधर से लूँ फिर मैं. In paper 2, when they asked to draw the optical element, can we draw the groups around the carbon in any way or in a particular way? It's the mirror image. You have to draw it y एक्सिस पे, उसको टिल्ट करेंगे. जो बिल्कुल टॉप वाली चीज़ होती है वो नहीं हिलती, जो राइट वाली होती है वो नहीं हिलती, लेफ्ट वाली लेफ्ट हो जाती है, राइट वाली और दूसरी वाली थोड़ी सी यूँ हो जाती है. शीशे में कैसे दिखेगा वो ड्रॉ करना है. Sir, I completely understand a mechanism, but in paper I always have to derive them from sketch because I forget. How do I improve? Write it 50 times. I got A stars, Murtaza. Why didn't you connect the Br to the second carbon? Which second carbon? Sir, didn't you connect the Br to the second carbon? ना, तो ये ट्रांजिशन स्टेट होता है ना, which exists for a very split second where carbon is effectively not making 5 bonds. इधर एक हाइड्रोजन भी होता है. वो स्केलेटल में मैं आपको कैसे दिखाऊं, लेकिन ये अगर बी आर है, ये ओ एच है, ये 50% टूटा होता है और ये 50% बना होता है. मोहम्मद, रिमेंबर? I think I'm going to call this part 1. So in SN2, can we flip the product on the y-axis? Yes, it's like an inverse umbrella, inverted umbrella. I think that's enough, yaar. I'm tired. Who did you do A O level from, dog? Murtaza, I did my A levels from Eastern College, did my O levels from Peshawar, Bloomfield Hall. Sir, आप इतने young कैसे हुए? Because I shaved, Hamza. You guys literally told me to shave. You guys said you look too old. Yeah, the other fellas told me to shave, Hamza. Even if it wasn't you, the other peeps told me. I'll call this part 1 because I swear to God it hurt my brain. Yeah, I'm a human being. I'm not a machine. Please try to understand this. Although I might be really good at chemistry, but I'm not a machine, am I? When my brain starts to hurt, it starts to hurt. I have worrying about it, yeah? Sorry for my pathetic attitude. सावर पैच ही क्यों खानी है? खानी है तो बस खानी है यार, यही है मेरे पास, और नहीं पड़ी हुई. Are you from Peshawar or its surroundings? What do you mean surroundings? Surrounding मतलब geography का पेपर दे रहे हो? Peshawar and its surroundings. I'm from Lower Dir actually. Lower Dir. I'm from a small village in Lower Dir called Moranai. Sir, were you the student who studied 12 hours a day? I promise you. I always, even in A levels, I started studying in, I swear, I'm not exaggerating this, like 20 days before the exam. 15-20 days before the exams. And A2 level physics I studied in 7 days. Because I was suspended from college back then. So, I'm not joking. I'm not lying. I'm not joking. I didn't even show up to the classes. For those who might think that sir class mein bahut padhte the, I had the lowest attendance. 2% मेरी attendance थी. Can we do the same? No. Sir, you were literally in HSN competition. Is insane there. Competition my ass. There's no competition in A levels. In HSN. क्या हो गया? I was a boarder. I was not a day boy or a day scholar. There's competition between day scholars. When they go to academies, they go to all these big, renowned teachers. We were boarders. We were just the shit. No, we used to play all day long. Nothing else. HN is good for exposure only. For making friends. I'm not gifted. I just knew how to work smart. How did you study in the last 10 days? Watch my 2 guidance videos, Junaid. But nahi, kitna bataun? You study smart. Be smart about it. देखिए, let me tell you something. In HN, even my friends who were not that good at studying or not that good with their concept. They got B's and C's in A levels. And back in Peshawar, the same batch that we all studied in O levels, we all got A stars and all. Those guys ended up repeating A levels, although they used to only study all day long. They did 20 years of past papers, because the problem was their mindset. They thought that A level is so difficult that when the paper came in front of their eyes, they were just bamboozled by the paper. They were perplexed, and that's why they got cooked. And then they repeated A levels. My subjects were math, physics, chem, and computer science. Although I hated physics and computer science. यार मैथ पता नहीं मैं कौन सा मर के किया था. मैथ में क्या झक मारे थे. बुक से पढ़ा था मैंने मैथ. I got a start. How did you get into accounting then? Because my dad did not want me to go abroad. To play Asphalt 8? No. I used to play. Who was your chem teacher in Peshawar? Yeah, I had many chem teachers in Peshawar. But again, I was normally kicked out of the class. Normally. I did not study from Ahmad Saya, but I've heard really good things about that dude. I've actually heard good things about that dude. Like, our professor in accounting and finance, he actually, recommended Sir Ahmad Saya to, a lot of us. KR, if somebody were to ask you who to study from, say Ahmad Saya, because that guy is low-key underrated. At least that's what I've heard from a lot of renowned teachers. And teachers who I personally, look up to. Like Sir Ahmad Razamir, he was our professor for multiple subjects in the chartered accountancy profession. So why were you suspended? Because I was just a lazy bum. That's why. And I was too cool for school. I never really used to listen to teachers. No. When teachers used to say this is this, I used to say why. And then I used to get kicked out. If a teacher used to tell me that mass equal mole times MR, I used to say why. Why? If the teacher used to say kinetic energy is equal to half mv square, I used to say why. And that's why I became a teacher, to answer my whys and your whys. I vowed to myself that I would never be a teacher who is not equipped enough to answer the whys of students. और अगर मेरे पास why का जवाब भी ना होता, तो मैं उसको सर्च करूंगा. I would never tell a student कि हाँ इस पॉइंट इन टाइम में अगर आप मुझे पूछे कि ब्लैक होल क्या करता है, तो मैं कहूंगा बेटा मर जाओ, आपके एग्जाम सर पे हैं, एग्जाम्स पे तैयारी करो, ब्लैक होल पे कर लेंगे डिस्कशन. But obviously, I'm not a physics teacher, so I still don't know why is kinetic energy equals half mv square. Ask a physics teacher this. But that's why I became a teacher. That's why I became a teacher. Because I vowed to myself that even if I don't know the why, I'll research on it and tell it to the student. After I got 8 A stars and 2 A's in my O levels and stars in my A levels. Bro was a rebel since day one. I got an A star in physics. That's what I'm saying. I want me to show you my script. Once I go back home, I'll send you a picture. But I hated physics since day one. I literally hated it. But our teacher wasn't good. The physics teacher also kicked me out of the class once. I hated my teachers. When I go home, I tell you when I go home. I go when I go. But that's the thing, guys. I sometimes think to myself, you guys are blessed to have good teachers now. Online good teachers like yours truly. अल्लाह करे मैं अच्छा टीचर हूँ. अल्लाह करे कि आप लोगों को ऐसे लगे. But the thing is, now that I think about it, our teachers, some of them were, really good, जिनको हम आज भी मैसेज करते हैं. जैसे हमारे एक टीचर थे मैथ्स के, सर ताहिर. सर ताहिर जो थे, he is a legend. He still teaches. He's a legend. He taught us back when we were in O levels, and the guy made us finish D1, D2, D3, जितने भी D's थे. He broke our fingers. Every day we used to dread his class. क्लासिफाइड से वो हमें पूरा क्लासिफाइड हमने किया था, पूरा D1 D2 हमने किया, हमारी उंगलियां तोड़ दी थी. लेकिन एंड वी यूज्ड टू, आई एम नॉट जोकिंग, वी यूज्ड टू अब्यूज हिम इन आवर हार्ट्स व्हेन ही यूज्ड टू गो आउट ऑफ द क्लास, इन आवर हार्ट्स एंड विद ईच अदर. और ये वो मेरी स्पोर्ट्स क्लास रोक देते थे जब मैं होमवर्क नहीं करता था. मैं स्पोर्ट्स क्लास में बैठ के उनको गालियां दे रहा होता था. आज I still give all my credit to that man. My math was very weak in grade 8. That man alone worked with me on my math, and I am what I am because of that man. मैं आज भी कहता हूँ कि सर ताहिर अगर हमारे साथ उतनी मेहनत ना करते ना, तो आज मैं शायद इस मकाम पे होता है ना, क्योंकि मैथ आपकी क्रिटिकल थिंकिंग और एनालिटिकल थिंकिंग अच्छी करती है. वो ब्लूमफील्ड हॉल में पढ़ाते हैं, पेशावर में. लेकिन अब मैंने सर से बात की रिसेंटली. सर कह रहे हैं यार आजकल के बच्चे वो वाली नहीं है, बात नहीं सुनते ना, मैं काम देता हूँ ना, वो बस चिल माहौल चल रहा है. मैं कहा क्या बात है. A2 with Sir Suleiman, let's see. Sir, my chemistry teacher kicks me out like twice a week. Junaid, likewise. मेरा भी यही हाल होता था यार. मैं बस यही था यार कि कोई मनहूस से लोग मिले थे हमें, मनहूस सी शक्लें थी, मनहूस से एटीट्यूड्स थे उनके. मुझे आज भी कुछ लोग मैसेज करते हैं. उस दिन मुझे एक टीचर का मैसेज आया, सर आई लव हाउ यू टीच रियली वेल, ब्ला ब्लू ब्ला, लेकिन आई एम ऑल्सो अ टीचर, और आप टीचर्स की इज्जत करना शुरू कर दें सर. ये है, आप टीचर की इज्जत नहीं किए. और नहीं बचे, पहले टीचर बन के दिखाओ. टीचर ना, लोग कहते हैं कि पुराने ज़मानों में टीचर की इज्जत होती थी, आजकल नहीं है. बकवास है, सरासर बकवास है. डू यू नो व्हाई? बिकॉज नाउ अ डेज आई सी स्टूडेंट्स रिस्पेक्टिंग टीचर्स मोर देन जो बैक इन द डे हम सुनते आ रहे हैं. डू यू नो व्हाई? बिकॉज आजकल टीचर्स की कमी है. आप अपने आप से पहले टीचर बनाओ. आप अपने आप को ऐसे बनाओ कि आपको स्टूडेंट्स आप टीचर कहने के लायक बन जाओ. पहले देखो आपके लोग कैसे इज्जत करते हैं, देखो आपके लोग कैसे तारीफी करते हैं, कैसे कैसे मैसेजेस आपको मिलते हैं. आपकी सोच है. दिस इज व्हाट अ टीचर ड्रीम्स ऑफ. जो बच्चों के रिजल्ट्स आते हैं, उनके मैसेजेस आते हैं, प्यार भरे, मेहनत भरे, वो असल गेम होती है. वो जो खुशी है वो कोई नहीं खरीद सकता. तो ये टीचर ने जो मुझे ये मैसेज की, मैंने उनको यही जवाब दिया कि सर ऐसी कोई बात नहीं, मैं टीचर्स की आपसे ज़्यादा इज्जत करता हूँ, लेकिन पहले टीचर्स बन के दिखाएं. ऐसे लोग जो टीचर्स नहीं होते और आके पढ़ा रहे होते हैं, बकवास कर रहे होते हैं, मैं उनको कभी टीचर नहीं मानता. सॉरी टू से, जो मर्जी. हालांकि आई डिसएग्री विद अ लॉट ऑफ पीपल जो कहते हैं टीचर जैसा भी हो, टीचर होता है. आई डिसएग्री विद इट. सॉरी. आप टीचर बन के दिखाओ, आपकी मैं सबसे ज़्यादा इज्जत करूँगा. आप टीचर नहीं हो, बच्चों का बेड़ा गर्क कर रहे हो, फ्यूचर गर्क कर रहे हो, और आप मुझे कह रहे हो कि मैं जैसा भी हूँ मेरी इज्जत करो. जाओ बाढ़ में, लख की लानत पड़े मुंह थे. आप जो है बच्चों का फ्यूचर तबाह बर्बाद करने पे तुले हुए, और आप कह रहे हो चूंकि मैं साथ टीचर का टाइटल है, प्राइमरी ग्रेड और ओ लेवल और ए लेवल पढ़ा रहा हूँ किसी मर के इंस्टीट्यूटों में, पैसे ले रहा हूँ बच्चों से और उनका फ्यूचर तबाह करूँ, लेकिन फिर भी आप मुझे टीचर बोला. सॉरी, दैट कैन नेवर बी मी. आई एम नॉट सेइंग यू शुड बी लाइक दैट टू. आई एम इन अ पोजिशन वेयर आई कैन डू दिस. आप अपनी टीचर्स की इज्जत करें जैसे भी है. I try to teach my friends what I learned from you, but they aren't interested in पढ़ाई. Junaid, then teach a mirror. पहले बच्चे उर्दू में बुरा कहते थे, आज इंग्लिश में. Good one, Hamza. Good one. Bro was a rebel since day one. Yes, Murtada. We're on the same side. Chalo guys, love you all. Bye.